Welcome to my YouTube channel where I teach chemistry for class 11th, 12th and for entrance examinations. Today I have come up with an important topic of general organic chemistry that is interesting, fascinating and equally important for examination point of view, that is mesomeric effect. It is also called resonance effect. Mesomeric effect or resonance effect. In the previous videos, we discussed inductive effect. You remember it very well. In inductive effect, molecule becomes polar due to difference in electronegativity between two atoms. And in inductive effect, sigma electrons, their displacement is responsible for creating polarity in the molecule. Polarity in the molecule is created due to displacement of sigma electrons. That's called inductive effect. Here in this topic, mesomeric effect or resonance effect, it also involves displacement of electrons along the carbon chain, but not sigma electrons. Pi electrons. Pi. You know pi bond? When pi electrons get delocalized, I will explain it using a simple example. What actually is mesomeric effect or resonance effect? This is a molecule. Its name is buta 1,3-diene. Buta 1,3-diene. It has two pi bonds, two double bonds, alternate. First double, then single, then double. So we have pi bond, then sigma bond, then pi bond. Such double bonds, such alternate double bonds are called conjugated double bonds. So alternate single and or simply alternate double bonds are called conjugated double bonds. And this type of alkene is called a conjugated alkene, in which we have alternate single and double bonds. Okay? Why I have picked up this example? Because it is in such systems that you will observe mesomeric effect or resonance effect. How it is possible? I will explain it to you. So alternate double bonds are called conjugated double bonds. See how pi bonds get delocalized. So this is butadiene. It is first structure. Alternatively, we can have it is second structure in which pi bond, this is sigma bond, this pi bond. Pi bond shifts towards one carbon, and this pi bond, it shifts like this. So creating polarization. So here we have separation of charge. This is second structure of butadiene in which separation of charge takes place. Why so? Because shifting of pi electrons, not sigma electrons. This shifting of pi electrons we call resonance effect or mesomeric effect. Remember, there is one more term, resonance. There are two separate concepts. Resonance is one thing and resonance effect is another thing. I am teaching you resonance effect. Okay? Got it? So, this pi bond alternate single and double bonds. They interact with each other, creating polarity in the molecule. This polarization due to shifting of pi bonds in the organic compound we call mesomeric effect. So this becomes polar separation of charge. I will give you a second example. Second example is lone pair on an atom. Lone pair on an atom interacts with adjacent pi bond or pi bonds. That is also called conjugation. Sometimes lone pair on one atom and adjacent pi bond, they also interact. That interaction is also called conjugation. I will give an example like this. CH2 double bond CH. This is Cl. Chloroethene. It is a non-polar structure. Now how it will attain polarity? Like this. Pi bond will shift towards carbon and this lone pair will move like this. It will form a double bond here. And it is second structure with separation of charge. It will become CH2 negative CH double bond Cl. And Cl will attain positive charge. So polarization, creation of polarity due to shifting of pi bonds. That is called mesomeric or resonance effect. Okay, what is the difference between inductive and mesomeric effect? In inductive effect, sigma bonds get displaced, sigma electrons. But here, pi electrons get displaced. Get my point? Yes, very good. Now I will write the definition statement. What actually is mesomeric effect? You may also note down it. Mesomeric effect is the mesomeric effect is the creation of polarity in the compound as a result of interaction between two pi bonds but remember pi bond must be alternate between two pi bonds or between pi bonds and adjacent lone pair of electron. Okay, so this shifting of pi bond which creates polarization, it's called mesomeric effect. Remember, it influences many physical properties of organic compounds: stability, acidity, basicity, melting point, boiling point, so forth and so on. And one more important point is, this effect helps us in explaining reaction mechanism. Reaction mechanism, to explain, to understand the reaction mechanism in a better way, this effect plays very important role. Got it? So it is called mesomeric effect. So what is the requirement for a molecule to show mesomeric effect? Alternate double bonds or double bond in conjugation with lone pair on the adjacent atom. One more point I will write. Mesomeric effect is permanent effect. Unlike inductive effect, that is partial, mesomeric effect is permanent effect. Number second, it is of two types. Number one, positive mesomeric effect, that's called plus M, or it's also called plus R effect. Positive mesomeric effect, what is that? When pi electrons get displaced, delocalized towards carbon chain, that effect we call plus M effect. Just like inductive effect has two types, plus I effect and minus I effect. Same is the case with mesomeric effect. So, shifting of or displacement of pi bonds or pi electrons towards carbon chain towards the carbon chain. Now, what type of groups will exert this plus M effect? They must be electron donating groups. So I will write electron donating groups. Exert plus M effect. Now I will give you some examples of groups which are electron donating or electron releasing groups which exert plus M effect. Now what are those groups? These groups: NH2 Okay, OH, OR, alkoxy. It's called amine, hydroxy, alkoxy. NH, COR, SH. What's SH? Thioalcohol. And halogens. Chlorine, fluorine, bromine, iodine. Halogens exert weak plus M effect. It's a very important point. Halogens exert weak positive mesomeric effect because they are more electronegative than carbon. They show strong minus I but weak plus M. So mesomeric effect can be plus or it can be minus. To explain how mesomeric effect takes place, I will give an example. Remember these groups: NH2, OH, OR, NHCOR, SH, and halogens. Now let's explain it with the help of a suitable example. See, this is chlorobenzene. Benzene, you know, it has alternate single and double bonds. It's a conjugated system. And chlorine, you know, it has 3 lone pairs. So chlorine has lone pair and this carbon, it has a pi bond. So lone pair will interact with these pi bonds. That interaction is called a conjugation. And it will be a good example of positive mesomeric effect. See how? First structure. Second is this pi bond will move towards carbon like this. It will form a double bond between chlorine and carbon. But carbon will become pentavalent. That is not possible. So pi bond will be pushed towards this carbon. It is called orthocarbon. What is the second structure we get? This one. Orthocarbon will attain negative charge and this chlorine will attain positive charge. See, molecule becomes polar. Chlorine donates lone pair towards carbon, towards conjugated system. It's called plus M effect. And these structures, you know, they are called resonance structures. Now what happens? These 2 electrons, negative charge equal to 2 electrons. They will shift like this between this carbon and this carbon. And this pi bond will be pushed towards para-carbon. Then we will get structure number 3rd. Para-carbon will attain negative charge. Double and double bonds. So structure 3rd. Then what will happen? This negative charge will shift like this. And double bond will be formed here. And this pi bond will be pushed again towards orthocarbon. Like this. Double-headed arrow means movement of 2 electrons. Then orthocarbon will attain negative charge. Then what will happen? Again we will get the original structure. It will move towards the ring and this pi bond will shift again towards chlorine. We will get the real structure, original. What is the purpose of this shifting of pi electrons? Conjugation gets extended and it helps in stabilization. Conjugation gets extended and molecule attains stability. Please, you can write these structures. So, interaction between lone pair and pi bond, it extends conjugation and it is a stabilizing process. I hope it is clear. This is one part of mesomeric effect or resonance effect in which molecule attains polarity due to interaction between pi bonds, alternate pi bonds, or between lone pair and pi bond. And in coming lectures, you will see interaction between pi bond and positive charge, pi bond and negative charge. That will also help us in understanding these effects and their role in different areas of organic chemistry. So at last I will write interaction between lone pair and pi bonds extends conjugation. It extends conjugation. This is stabilizing process. This is stabilizing. Thank you very much for watching my video. Please subscribe my channel for the lectures.